Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. Now in this video, I solved series of problems on moment of force about a point, and if you want more discussions on the concept, then you visit my other playlist on Statics, your one-stop channel. There, there were, or there are so many examples where you can base the solutions here. So a 300-pound force is applied to the rectangular plate at corner C. Determine the moment of this force about pin E in multiple ways. So here is the given figure. So first way is using the direct distance of or moment arm of the 300-pound force from E. So let's call it distance E. The distance from E to C can be solved because this is 8 inches and this is 15 inches. So square root of 8 squared plus 15 squared, that would be 17 inches. So we need this angle here. For this angle here, we need this drawing here. This is also 53.13 degrees. This is the extended line of action of the 300-pound force, and it makes an angle of 53.13 degrees with horizontal. Then in this right triangle CDE, this angle is arctan of 15 inches CD divided by 8, and that is equal to 61.928 degrees. Again, arctan of 15 over 8. Then this angle, the measure of this angle is, because this is a right triangle, 90 degrees here, 90 minus 53.13 degrees is 36.87 degrees. Therefore, the measure of this angle is 61.928 minus 36.87, and that is 25.058 degrees. This perpendicular distance D sub E, therefore, is 17 cosine of 25.058. So the moment of the 300-pound force about E is 300 times D sub E. So 300 times 17 cosine of 25.058 degrees. It is counterclockwise. And the magnitude is equal to 4620 pound-inch counterclockwise. For the second method, we have to resolve the 300-pound force into components. Horizontal is 300 cosine 53.13 degrees leftward, and that is equal to 180 pounds. The vertical component is 300 sine 53.13 degrees, and that is 240 pounds. So the moment of the horizontal component is counterclockwise. The moment of the vertical component is also counterclockwise. So ME equals 180 times 15 plus 240 times 8 inches. And that is equal to 4620 pound-inch in counterclockwise direction. Then third method is by principle of transmissibility of a force. We transfer the components of force here along its line of action, as shown in the figure. So let's remove this. So only the vertical component of the force will have moment about E, and it is counterclockwise. So we need distance D sub D. This distance D sub D can be solved in this triangle CE and this corner here by sine law. So the measure of this angle at C is 180 degrees minus 53.13 degrees minus 61.928 degrees. So 180 minus 53.13 degrees minus 61.928 degrees is 64.942 degrees. So by sine law, distance D as to sine 64.942 degrees equals 17 inches as to sine 53.13 degrees. So distance D is equal to 19.25 inches. Therefore, the moment of the force is also the sum of the moments of its components. The other component will have zero moment at E. This vertical component has moment which is counterclockwise to 40 times d sub d, which is 19.25. So moment at E is equal to 620 pound-inch. The other method which I leave it to you is move the force along its line of action there at the top. Find that point, find this distance, because the moment of the force is equal to 180 horizontal component times that vertical distance. So I will leave that to you. Take note, this is 53.13 degrees and this is 8 inches. So you can find this vertical distance extension. But I leave that to you. Solution 4 is by vector approach. So we apply cross product and the moment at T is R position vector EC, then we cross it with the vector of the force. So moment at E in vector form is REC cross the force, where REC is from here to there is moving rightward and upward. So REC is 8I, this is the x-axis, then y-axis 8I plus 15J, REC. Then the force is in vector form negative 180I plus 240J. Then arranging in the cross product approach, basket method, components of REC, components of the force, IJK, unit vectors, copy the elements of the first two columns, then apply basket method. You proceed directly to K because I and J will be definitely zero, because moment of the 300 force would be about the axis through E. So if this is the X, Y, then rotation is about axis Z, which is K. So 8 times 240, then minus negative 180 times 15. So it is 240 times 8 plus 180 times 15. So if you notice from this equation, it's the same. So ME is 240 times 8 plus 180 times 15K. So moment at E is equal to 4620 pound-inch, or in short, that's 4620 in scalar approach. So there are 4 solutions here. The fifth is, as I said, you find that point there, then you sum up moment about E. Then for your part, a crate resting on the ground is acted upon by the 120 Newton force shown. Determine the moment of this force about corner A in at least 4 ways. So you do the same thing, and this is 120 Newton force. This is corner A. So show that moment at A is 99.85 Newton meter clockwise, moment at A. That's it. Then present solution in 5 ways. So let's proceed to problem 66. Determine the moment of the 60 Newton force about point A in 2 ways. So just 2 ways. This is the figure. So for the solution, first way, let's resolve the force into 2 components, 60 cosine 15 leftward and 60 sine 15 upward. Because this is 75 degrees, the vertical distance from A to C is radius 0.25 sine 75 plus another radius because A is the lowest. So this is 0.25 sine 75 degrees plus 0.25 in meter. Then this horizontal distance is simply radius cosine of 75. So 0.25 cosine of 75. So we can now compute the moment about A. The horizontal component is counterclockwise, the vertical component is clockwise. So we treat counterclockwise positive. Moment at A is 60 cosine 15 times quantity 0.25 sine 75 plus 0.25 degrees minus 60 sine of 15 degrees times 0.25 cosine of 75 degrees. So using your calculator, the moment at A is equal to 27.48 Newton meter counterclockwise. For the second method, let's have the force times perpendicular distance. So this is the perpendicular distance d sub A, and this is distance from A to the point where the force acts, and we can find that as square root of this distance, horizontal distance, because this is a right triangle, plus this vertical distance square by Pythagoras theorem. The angle that dA makes with the vertical is also the angle of inclination of the force, because this is perpendicular to the line of action of the force, so it's also 15 degrees. So that's d sub C. So that's 15 degrees, and let's call this angle here to be determined theta, that very small angle. Therefore, d sub A is d sub C cosine of quantity theta plus 15 degrees. So for solution 2, moment at A is 60 times d sub A, where d sub A is d sub C cosine of quantity theta plus 15 degrees. Actually, theta is expected, if you're good in math, as half of 15, because this arc here subtends an angle of 15 degrees. That's 15 degrees, 90 minus 75. So a point on the circumference subtending the same arc by principle is half that central angle. So if the central angle is 15 degrees, then theta is half of 15 degrees. That is a principle which can be proven in plane geometry. But if you're not familiar with that, there's no problem as long as you can solve for theta, arctan of 0.25 cosine 75 degrees divided by this entire value here. So d sub C is square root of 0.25 sine of 75 plus 0.25 quantity square plus quantity 0.25 cosine of 75 degrees quantity square. So d sub C is equal to that 0.495722 meters. And tangent of theta is opposite 0.25 cosine 75 degrees over quantity 0.25 sine 75 degrees plus 0.25. So theta is really half of 15, 7.5 degrees. Then we can also moment. So moment at A is 60, quantity 0.495722, cosine of quantity 7.5 degrees plus 15, or 22.5 degrees. So the moment at A is the same, 27.48 Newton meter counterclockwise. So that's it, because the instruction is just moment about point A in two ways. But supposedly we are not obliged to present so many solutions, just one enough. But if in the problem we are required by that certain number of ways, then we must follow that. Determine the moment of the 60 Newton force. This is your part about point O, so about the center, in two ways only. So these are the answers. 12.99 Newton meter counterclockwise, and that's it. Then for the last part, control bar AB is inclined at 50 degrees from the vertical. A 10-pound force is applied to the bar at end D. Determine the moment of this force about pin A if the force is horizontal. So part A, if the force is horizontal, then in the second part, P is 120 degrees. Here is the figure. So if the 10-pound force is horizontal, let's have a drawing to analyze it easily. So we have 10 pounds horizontal. This vertical distance or moment arm of 10 pounds would be 2.5 cosine of 50 as shown. So this is 2.5 cosine of 50 degrees. Therefore, the moment of this force about A is 10 times 2.5 cosine 50 clockwise. So moment at A is 10 times 2.5 cosine of 50 degrees. Moment at A is 60. Moment about A is 16.07 pound-foot clockwise. For the second part B, if P is the whole of this angle is 120 degrees. So that's the force. This is 120 degrees. The angle that the vertical makes with AB is also 50 degrees as shown. So since this entire angle is 120, so this is 70 degrees, 120 minus 50. So there are two components of the 10 pound force, horizontal, which is 10 sine 70, and the vertical, which is downward, 10 cosine 70. So we need the moment arms 2.5 cosine 50, and the moment, and this distance is 2.5 sine of 50 degrees. The horizontal component is clockwise, the vertical component is clockwise, so we treat both of them as positive clockwise. So moment about A is horizontal first, 10 sine 70 times 2.5 cosine 50 degrees, then plus the vertical component is downward, 10 cosine 70, and the moment arm is 2.5 sine of 50 degrees. So 10 cosine 50 degrees, 10 cosine 70 degrees rather, times quantity 2.5 sine of 50 degrees. So the moment at A is equal to 21.65 pound-foot if P is 120 degrees. Now for your part, a 5 kilonewton force is applied to the bent arm at point A. Determine the moment of the force about point C if theta is 0 degree and B theta is 30 degrees. So here's the given figure and these are the answers. So I will leave that to you. Pause the video and verify that those are the answers. So that's it for this video.